What if the world's most dangerous choke point had a hidden backup system behind it? Right next to the Strait of Hormuz, a narrow passage that controls nearly 20% of global oil, Saudi Arabia built something massive. Not just a port, but a mega system designed to move millions of barrels of oil every single day. This is Ras Tanura, the largest oil export terminal on Earth. But here's the real question. If Hormuz becomes unstable, can this megaport keep the world running? Stay with me, because this isn't just about oil. It's about who really controls global energy. The Strait of Hormuz is not just a narrow passage, it's the most critical choke point in the global energy system. Every single day, over 20 million barrels of oil pass through this tiny corridor, fueling economies from Tokyo to Toronto. For countries like Saudi Arabia, Iraq, and the UAE, it's the only viable export route. Billions have been spent trying to bypass it, like pipelines across deserts, but none come close to replacing its capacity. This creates a dangerous reality. One small disruption here can send shockwaves across the entire world economy, making energy prices spike and supply chains unstable almost instantly. Now imagine this. Within days of rising military tensions, tanker traffic drops by over 90%. Ships are stranded, insurance costs skyrocket, and global oil prices surge past $100 per barrel. This isn't theory, it's a real scenario unfolding during conflict. Missile threats, drone surveillance, and naval warnings turn Hormuz into a high-risk zone. The result? A near paralysis of the world's most vital energy artery. For industries in the US, Europe, and Asia, this means delayed shipments, rising costs, and economic pressure. When Hormuz becomes unstable, it's not just a regional issue, it becomes a global crisis affecting millions. Behind this fragile choke point lies Ras Tanura, the largest oil export terminal on Earth. This isn't just a port, it's a massive energy control hub, moving up to 6.5 million barrels of oil per day. Connected to vast desert oil fields through thousands of kilometers of pipelines, it acts like a master valve of the global oil system. Giant storage tanks, high-pressure pumping stations, and offshore loading platforms work together seamlessly. From here, oil is pumped directly into massive tankers heading to global markets. Without Ras Tanura, even the world's largest oil reserves would be useless, because oil only has power when it can move. At the core of Ras Tanura's operation lies its pier and causeway system, an engineering masterpiece built over unstable seabeds. Instead of traditional foundations, massive steel piles were driven deep beneath soft marine clay to support the structure. This created a stable corridor connecting land-based pipelines directly to offshore tankers. Advanced loading arms adjust with waves, allowing continuous oil transfer even in harsh conditions. The design ensures that even the largest tankers can safely dock and load millions of barrels without interruption. This backbone is what keeps the entire export system running, turning raw and naphtha into global energy supply. Beneath the waters of the Persian Gulf lies an invisible but critical system, the Subsea pipeline network. These massive steel pipelines transport millions of barrels of oil daily from onshore facilities to offshore loading points. Built to withstand extreme pressure and corrosion, they are coated, welded, and carefully placed into seabed trenches for protection. This underwater lifeline ensures a continuous, uninterrupted flow of energy. Even if surface operations face challenges, these pipelines keep the system alive. It's a hidden infrastructure that most people never see, but without it, the global oil supply chain would break instantly. Saudi Arabia's massive port near the Strait of Hormuz doesn't just export oil, it controls a key artery of global energy. Here's the question: if the port or strait shuts down tomorrow, who controls the oil? Iran, Saudi Arabia, or the United States? Comment below. Comment your thoughts, because the answer could reveal who truly controls global energy.